Welcome to the lesson on polymorphism in C#. In this lesson, we will explore the concept of polymorphism, its significance in object-oriented programming, and how to implement it using shared interfaces and overridden behaviors in C#. By the end of this lesson, you should be able to write flexible and reusable code that takes advantage of polymorphism. Don't worry if this feels new at first. Now we're on understanding polymorphism. Polymorphism is a core concept in object-oriented programming that allows objects to be treated as instances of their parent class, even if they're actually instances of derived classes. This means that a single function or method can operate on different types of objects. There are two main types of polymorphism in C#, compile time or static polymorphism and runtime or dynamic polymorphism. Compile-time polymorphism is achieved through method overloading and operator overloading. Method overloading occurs when multiple methods have the same name but different parameters. For example, this slide introduces a class definition. Study the structure in the code sample. In the example above, the method add is overloaded to handle both integer and double parameters. The appropriate method is selected at compile time based on the arguments passed. So, runtime polymorphism is achieved through method overriding, which occurs when a derived class provides a specific implementation of a method that's already defined in its base class. This is commonly used in conjunction with interfaces and abstract classes. To demonstrate runtime polymorphism, let's create a simple example involving a base class called animal and derived classes dog and cat. This slide introduces a class definition. Study the structure in the code sample. In this example, we define a base class animal with a virtual method speak. The derived classes dog and cat override the speak method to provide their specific implementations. Now, let's see how we can use polymorphism to create a list of animals and call their speak methods. The class shown on screen and how its members are organized. When executed, this code will output woof, meow. Let's move on to using interfaces for polymorphism. Interfaces play a crucial role in achieving polymorphism. By defining a contract that classes can implement, you can ensure that different classes can be treated interchangeably. Let's create an interface called iVehicle and two classes car and bike that implement this interface. This slide introduces a class definition. Study the structure in the code sample. Now, we can create a method that accepts a parameter of type iVehicle and calls the drive method. Review the class shown on screen and how its members are organized. In this lesson, we learned about polymorphism, focusing on runtime polymorphism achieved through method overriding and compile-time polymorphism through method overloading. We also explored how interfaces can be used to create flexible and reusable code. Understanding polymorphism is essential for writing code that's easier to maintain and extend. Alright, your turn. Give this a try. First, create a new base class called shape with a method draw. Implement derived classes circle and square that override the draw method. Also, define an interface called iWorker with a method work. Create classes engineer and manager that implement iWorker and provide unique implementations of work. Finally, write a program that creates a list of shapes and calls their draw method to demonstrate polymorphism.